Okay, that's all I got.
I'm pretty sure it's like diagonal or something.
Okay, that's pretty good. We're going to go with that. All right, more on torque. We already know torque is radius cross force, R cross F, and of course it is a cross product. So we've done a few problems where we just had to find the perpendicular components. That was fine. But we can apply that to unit vectors as well. And torque can also apply to any particle that moves along any path relative to a fixed point. Of course, assuming there's a force acting on it. And if we have our unit vectors, we can do the cross product with them as well. So remember your right-hand rule. If something is spinning, sometimes it's kind of easy just curl your fingers the way it's spinning. But technically using this formula, it says take your right hand, point your fingers along the direction of R, whichever way that might be, and bend it towards F. So let's say, and of course these have to be perpendicular, so anything that's in the same plane or in the same line would be 0. So if I have I cross J, I want to know what's the answer as far as IJK would be concerned. So I'm going to try to visualize my coordinate system. Let's say the one coming at you is K. So we've got I to the right, J up, K that way. So we're doing I cross J. Your right hand. Okay, so first my fingers need to point towards I. So I is that way, so somehow like this, pointing towards I. And I've got to curl my fingers towards positive J. So that would be up. Does that make sense? J is up. So thumb is the answer. Well, it's okay. Which I think I need to write in. Yes, this is my favorite test. All right, what's the opposite? Do you think it's also K? J cross I. So J is up.
That's going to be K negative.
Good. J is up. Bend your fingers towards I. Thumb would be negative K. Okay. J cross K. J's up. Curl your fingers towards K. There's one coming at you. Good. I. And I cross K. Last example.
Wait. Down is negative J. And then like this?
I's that way. Then towards K. K is at you. Thumb is down. So negative J.
Why?
J. K. I don't know, I saw you yelling at letters. Why?
It's the only one missing. It's just whether matching them with positive or negative.
It's true, it is the only one missing, and then you gotta think about your signs. I's this way. J, what are we doing? K. K is at you. So towards the K, thumb is down. Negative Y, negative J.
It's just so overly complicated way of doing it. Yeah.
Okay, well if you want to like memorize a little chart of it, go ahead. All right, so 277. And we got a bunch of checkpoints. So, who's the lucky winner going to be, Zach? What's your guess?
Okay. Tyler. Spirits are with me today.
Lottery.
Really, Tyler?
It was Tyler.
I will read your prompts.
Okay, this is sort of a similar question here, Tyler. All right, so we have page 277, checkpoint number 3. The position vector R of a particle points along the positive direction of the z-axis. If the torque on the particle is 0, in the negative direction of x or the negative direction of y, in which direction is the force producing the torque? So it's kind of like these problems, except this was the direction of the torque. It's telling you the direction of the radius. It's telling you the direction of the torque. You got to kind of back it up to find the direction of the force. Okay, so
I thought if you multiply 2, never mind.
we're just talking about direction. So R is in the positive z axis. So we'll say that's like coming at you guys. So Tyler, if the torque is 0, what would have been true about the force? Okay, it could have been 0, or which way? We would simply have to match the same. Here is a cross product, so if they're in the same line, there is no perpendicular component. Okay, Tyler, what if R is still in the z direction, but the torque is in the negative direction of x? Let me just get these back out. So I know my hand's coming at you originally. The R is in the z direction, but the torque is in the negative direction of x, so your thumb somehow needs to end up pointing that way. So which way did you curl? Which way was the force? R's this way, thumb ends up this way. Up, good. So the force must have been up, which would say positive y. That's the only way we'd get our thumb pointing in the negative x. All right, one more, Tyler. This time the torque is in the negative direction of y. So our thumb needed to end up pointing down. R is still positive z. Very good. Negative I. So at you for the R, cross to the F, which was negative I. That way I'd get my thumb pointing down. Very good. You guys are going to enjoy that part of the test. Yes, yes it is. Okay, applying that to a problem quickly. You have your R here, says what's the net torque about the origin on a flea located at these coordinates when it's 2 forces on it. So net torque, I'm just going to break it into torque 1 and torque 2, and then we'll add it up. I'm just going to stick the I, J, and K on there. Cross 3K. And then torque 2, of course, R across that F. Okay, so what's 0 times 3? 0, don't care about that part. What is K cross K? 0, don't care about that part. So I just need to do this and this. Now when you have like -4, I just like to keep the negative sign with the number.
Pardon this interruption. I need any girl that plays.
I like to keep the number and the negative sign together rather than thinking about it as negative j, think about it as -4. So what's -4 times 3? 35, good. Let's go with the -12. Now we've got to do j cross k. J cross k.
You're
I.
J's up, K's at you. It's I.
Wait. Wouldn't it be negative I? Because it's negative J.
No, negative 12.
That's why I'm saying ignore the negative sign. Just do J and K. Keep the negative with the 4.
So how are you supposed to do that though if it's negative 12 on a positive I?
Well, you're right. That does mean negative 12I. Like, it does mean to the left.
So, but if it was like, if they were both negative, or I don't know,
If it
Yeah.
was still a negative I, would it be a positive?
12.
If there was a
Yeah,
negative
when the
12
two
negative
negatives are
I?
positive, basically.
You could have done... You could have thought of it like that, if you wanted to. And then you'd have 4 times 3 is 12. And then if you want to do negative J cross K,
But what if the K was, what I'm saying is like, if the K was...
that
negative,
still gets you
what-
negative.
What two negatives make... that
Yes, 2 negatives will make a positive, yeah. Sorry. I get you now. All right, so that's just torque 1, torque 2. Okay, 0 times 2, don't care. J times J, don't care. Or cross K, I should say. All right, 5 times negative 2? Negative 10. K cross J. Did we just do that? No, we did
J
J.
cross K.
We did J cross K. Ah, so this might be,
It's the
So
negative.
would it be like negatives?
for example, K.
No, negative I.
Yeah, so you're right. So this is a case where we would have 2 negatives. And then negative would just become positive. So now combine them. We've got negative 12, positive 10. They're both I. Total net torque would be negative 2I.
A lot of torque.
That's a lot of right hand rule.